of last year's exam. So it says, find the inverse and state the restriction. So first of all, how do we even find the inverse? What are the steps? Good, switch x and y. So we know f of x is the same thing as y. So we really have y is equal to 4 over x plus 2. Now when finding an inverse, we switch x and y. Wherever there's an x, I write a y. Wherever there's a y, I write an x. So we have x is equal to 4 over y plus 2. Correct, everybody? Second step is algebra. Solve for y, right? Get y all by itself because then we have a function. Y equals something. So let's do this algebraically. There's many different ways of doing this. First of all, I see that I have a y in the bottom of a fraction. Does everybody see that? So I'm going to fix that right off the bat. There are 10 different ways of fixing this. This is the way I do it. I'm going to flip the fraction. But if you do that, you've got to do it to both sides of the equation. So I'm going to flip this side, and I'm going to write y plus 2 over 4. Well, then you have to flip this side. So we'll have 1 over x. Does everybody see how I flipped both? Haven't I done the same equal thing on both sides of the equation? So we're good. Then from there, let's solve for y algebraically. So we have y plus 2 divided by 4. What do we need to do first? Good. Let's get rid of 4 because it's division. Multiplication is the inverse of division. So we multiply both sides by 4, right? So on this side, don't you multiply straight across? So we have 4 over x is equal to, the 4's divide out, right? So y plus 2. Last step to get y along. Subtract 2 from both sides of the equation. So on this side, we're going to have 4 over x minus 2, right? Is equal to y. And now you say, oh, there's my inverse. Y is alone. So we would write it like this. F inverse of x, that was kind of a weird one, is equal to 4 over x minus 2. Does everybody just see how I wrote it in proper notation? What? What's your question, sir? Okay. There was other algebraic ways of going about solving for y. You would have ended up in the same spot, though. Okay. Okay, let's get to it. So we know in this unit, guys, really everything you've learned, and everything we're learning, you should have learned in secondary 2. It's just in secondary 3 we make it a little bit more advanced. So let's get going with today. So today we're going to be finding areas of circles, which I know you know how to do, and then we're going to be finding area of sectors, which simply means sections of circles. So first of all, just remember, and this is something, like I said, this unit will be the most unit that will prepare you for the ACT. So it's a really good thing. I was looking at this and I'm like, oh, we've got to do this unit right now because their ACT is coming up. Okay, so remember, area of a circle. This is a formula you will need to have memorized for your ACT exam just forever. Okay, so area of any circle for the full circle is area is equal to pi r squared. We all know that, right? Okay, awesome. Now, so looking at this example here, we have a radius of 2 centimeters. So the area would be pi times 2 squared, which is 4 pi, right? Because 2 squared is 4 pi. So that's the pretty answer. The decimal answer is 12.6, and then we would say centimeters. Questions on that? Pretty easy, right? Area of a circle. Okay, so now here is the formula for area of a sector, but really it's just the same formula as area of a full circle with just one little tweak, which actually makes a lot of sense. So here's the area of a sector formula. It's the measure of arc AB divided by 360 times pi r squared. So now, if you think about it, before we just had this gone. It was just pi r squared. So now we're just taking into consideration, we only are finding the area of this piece out of the full circle. Does that make sense, everybody? That's why we take this divided by 360. Because we only want the area of this piece out of the whole circle. Does that make sense, everybody? So it's actually quite easy to remember. So you'll want to write that down, but once again, just one little tweak on this. So here's our first example. It says find the area of the shaded region. So I've highlighted it. So we're finding the area of just this piece of the circle. It's called a sector, this section of the circle. So we don't want the full circle, so we're going to take 30. We want the area out of 30 out of 360, right? That piece out of the full circle times by pi times the radius squared. So pi times 12 inches squared. So then you'll just type it into your calculator. We do want the pretty answer. So remember, multiplication is straight across. So you'll do 30 times 12 squared. Don't type it in with a pi. You write pi as pi divided by 360. So we get 12. 12 pi inches. square inches, I guess. Did everybody get 12 when you typed it in? And then pi, right? We still have the pi. We won't forget about it, but we'll write it like this. This is our pretty answer. And then once again, if you wanted the actual physical amount without the pi, you just type in 12 times pi into your calculator. Questions on that? So pretty simple, right? Okay, so another couple things to remember. These are all things that we have learned in the past math, either in this class or in previous classes. So remember, to find the area of a right triangle. Now what makes it right? The 90 degrees. If you have a 90 degree in any triangle, so this is a 90 degree triangle, or this is a 90 degree triangle, you can use the formula for area as such. Area is equal to 1/2 times the base times the height, right, everybody? So we know that, but then also, it's kind of cool because in secondary 3, we learn how to find the area of any triangle. So guess what? This formula even works for right triangles, and it truly does. You can find the area of any triangle, even if it's not right, by this formula, which we just learned. And we just tested on it. So we have area is equal to 1/2 times side 1 times side 2 times by sine of the angle in between, right? So this is side 1, side 2, and then there's the angle in between. So we would multiply that out. There's our area. So I usually, 9 out of 10 times, use this formula because I know it works for anything. Does that make sense? But if you do have a right triangle, you can use 1/2 times base times height. Is everybody comfortable with that? Okay. Okay, so we're going to need those things. That's why I brought it up. Okay, so let's just do one more example of finding the area of this sector. So first of all, we're finding the area of this section, the shaded region, the highlighted region. So are we going to use 288? Nope, right? That's not, we would be finding the area of this section, right? So we'll do 288 minus, 360, right? Minus 288, which is 72. So we're going to be using 72 degrees. Is everybody comfortable with why I did that? Okay. So now we know the area of a circle, but we're doing a section. So we're taking 72 out of 360 degrees, and then it's pi r squared. So pi times the radius, which is 15 squared. So the pretty answer, 72 times 15 squared divided by 360. The pretty answer is 45. So our area is 45 pi. And it's pi, I didn't specify inches, centimeters, so that's good enough. 45 pi. Pretty simple, right? I think you can all remember that. Okay. Do 9 through 17. All right, guys, I just teach it. I don't give you like a formula for it because the formula is just calculating what we're about to do. So it's easy just to think through this one, kind of. Okay, so looking at this, we're finding the area of this segment. So notice, we're just finding the area of this highlighted segment. So that's a pretty small piece. So now a couple of things to recognize in that piece. Don't we have a sector of a circle, which a sector is like a piece? Do you see the full sector? Then don't we also have a triangle in the sector? Okay, so if we found the area of the full sector and then subtracted out that triangle, wouldn't that give us this piece? So that's how we're going to do it, and that is the formula. They say take the area of the sector, subtract it from the area of the triangle, that will equal the area of the piece, which is what we're doing. Do you get what I'm saying, everybody? Okay, so let's find the area of the whole sector. So what we're going to be finding is the area of the full section here. So we know we do that by doing area is equal to the degrees, the section, which is 60 over 360, times by pi radius squared, so times pi 18 squared. So let's get that. So we have 60 times 18 squared divided by 360 is 54 pi. Does everybody understand how the area of the sector is 54 pi? That full thing. So the whole thing filled in would be 54 pi. Questions on that? Okay, so now we need to find, because we don't want the area of the full sector, we only want this piece, we need to find the area of that triangle. Now, is it a right triangle? No, right? It's not. Do you see the 60 degrees, people? Not right. So we know that we can still find the area really easily. Side 1, which is 18 times, 1/2 times side 1 times side 2, which is 18. Does everybody understand? 18, 18. Yeah. times by sine of the angle in between, which is 60. Make sure your calculator's in degree mode because this is degrees and we're typing it in. So type it in, 0.5 times 18 times sine of 60. So our area is 140.3. Rounding to one decimal place. Of that triangle, right, everybody? So that's what the triangle. So this is 140.3. So if you take the full amount and subtract off the triangle, that will give us the leftover, right? Let's do that then. 54 pi minus 140.3. So yeah, we're going to just write these in decimals. So 54 pi minus 140.3. Yep, so 29.3. So that section, guys, that little piece, had an area of 29. I'm having like dyslexia today. I really am, aren't I? Okay, so 29.3. When I think and talk at the same time, and these problems kind of you have to actually think about, sometimes I write down weird things. 29.3. Is everybody good with that? You need to do another one.
Do one more.
Okay, let's do one more, yeah. So find the area of this segment. Okay, so looking at this segment, we only want this piece. So once again, if you look and notice a couple things, we have a sector and we have a triangle. And then if we were to subtract off that triangle amount from the full sector, then we'll have that section. We'll notice something. We don't have an angle. We know this arc's 120 degrees. So can anyone tell me what we know, given that? Yeah.
Isn't it because percentile equals the same as your arc like this?
Awesome. So this is a central angle and it's opening up on that arc, right? A central angle is equal to its intersected arc. So if this is 120 degrees, this must be 120 degrees. Way to remember that. Okay, so here we go. Let's find the area of the full sector. So we will have 120 divided by 360 times by pi radius squared. Pi. So the full sector, if you're filling that full section, would be 12 pi. Now we're going to find the area of the triangle. Once again, not a right triangle. Even if it was right, we could use this formula, which is 1/2 times side 1, which is 6. Oh no, I only have one side. What am I going to do? Isn't it the same? This is a radius of 6, wouldn't this be 6? Okay. So side 1 times side 2 times by the sine of the angle in between. 15.6. So now we'll take the full sector's area, subtract it off from the triangles, and that will leave us with the leftovers. So 12 pi minus 15.6. 22.1. So the area of that section right there was 22.1 centimeters. Questions on that? Questions on that? Okay. Do the front of the worksheet. Ready, set, go. You'll want to be with me through this one. And then I'll let you work and finish up, but we won't be finishing the whole worksheet. So just a couple more off the bat. So now we're just kind of putting it all together. Everything we just learned all together. It looks a little bit harder than it really is. So it says find the area of the shaded region. This is number 26 on your worksheet. So if you do it with me, you have one less problem to do. So looking at the shaded region, we can do this many different ways. So I actually thought about it. I went through and did it the long way, and then it hit me a little while later that there's probably an easier way. So let's see. Can you guys come up with a method to find the area of the shaded region? Think about it. How could we find the area of the shaded in region? Yeah.
Find the little area and then subtract that.
So you're saying subtract this. Find this area, so we know how to find that, and subtract it from the area of the full circle. That's a great method. I actually use that. Yes, there's another method. Can anyone think of another method? Yeah.
Find your circumference and put in your triangle and then subtract it, whatever you're supposed to do. Right?
So the circumference would be the outside, right? But we want the full in area, but you're on the total right track. You are right there. Anyone?
One masonry. Yeah.
I like that idea. You were saying find the... Oh, you're saying we could figure out this sector's degrees, and then can we find the area of that sector, and then add it to the area of the triangle? So we have two different ways of doing it. That's going to be quicker, so I'm going to do it that way. So, do you guys understand? So that's kind of what you were getting at back there. You were saying, well, we can figure out kind of this, right? He's not listening. Okay. So we have 360. This is 60 degrees. So what's this? 300 degrees. So now we can find the area of this piece. Ding, 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 ding. So area is equal to, of a sector, 300 divided by 360 times by pi r squared. So we have 300 times 8 squared divided by 360. 160 pi thirds. So that's the area of that section, and now we'll find the area of the triangle and add it up. That's actually the easiest way. But you could do it the other way. So area of that triangle is not right, so I'm doing 1/2 times side 1 times side 2 times by sine of the angle in between. So 0.5, 8 times 8 times sine, that's 60. Area of that triangle is 4.01, so it's 4.0. So now we'll add those up, right? 160 pi thirds plus 4. Because I typed in 1/2 times 8 times 8 times sine of 60. Oh, I didn't type that in right.
I got 27.7.
Yeah, I didn't type it in right. Yeah, I didn't type in this right. I accidentally pushed a weird button on my calculator as I typed it in. So 0.5 times 8 times 8 times sine of 60. Sorry, yeah, you're right. It would be 27.7. So it'll be plus 27.7. $195.3. Is everybody good with how to do that? Okay, so these are what are required of you to do. 26 to 31.